Lesson 23. Who else would I rather have in the background for lesson 23 than number 23, Michael Jordan? One of the greatest of all time. I know some of you are probably thinking, well, Mr. Briscoe, LeBron's better. Come on. Fine, have your opinion. I'm just telling you, the guy could play. All right, Michael Jordan, legend. All right, so we're going to talk about zero exponents first. Anything raised to the zero power is always equal to 1. And you can prove that on your calculator if you want to just take some numbers, start raising them to the zero power. You'll see that they're 1. We actually had this discussion back at the beginning of the year when we were talking about powers of I. All right, we learned that I raised to the zero power is equal to 1, and I showed you why, but I'll remind you of that real quick. If I have something like 3 to the 4th power over 3 to the 4th power, if you use your exponent laws, which are if the base is the same, you subtract your exponents, this turns into 3 to the 0 power. All right, so if I do this same problem though in another way, by actually taking 3 and raising it to the 4th power, I get 81. And 3 to the 4th power again is 81. And 81 divided by 81 is 1. So working it one way, I get 3 to the 0. Working it the other way, I get 1. So your logical conclusion is that 3 to the 0 must be 1. So anything raised to the 0 power is 1. Now there's a couple of tricky things that can happen with zero exponents that I'm going to show you. All right, just 2 real quick things about zero exponents. All right, you see I got 2 examples here. I have 2y to the 0 power, but I also have 2y to the 0 down here, but one has parentheses and the other does not. So you just got to watch out for this. If it's in parentheses like this, that means everything in here is being raised to the 0 power. So it's going to follow our rules that anything to the 0 power is 1. So the answer to that one is 1. But down below here, the only thing being raised to the 0 power is the y. The 2 is not part of that anymore because there's no parentheses. So that 2 stays as is, and then y to the 0 is 1, because anything to the 0 power is 1, and then 2 times 1 is 2. So that's a little tricky, parentheses versus non-parentheses. I'm going to show you something like that with negative exponents as well, so we're going to do those now. All right, to show you how negative exponents work, let me just put an example problem up here and show you how it all comes together. So if I have x to the 3rd over x to the 7th. So using your division rules, when you have bases the same, your rule is you subtract your exponents. So if I subtract those exponents, 3 minus 7 gives me negative 4. Now we don't really like to keep exponents negative. There's nothing wrong with it, it just kind of looks messy. So let me show you what x to the negative 4th is actually equal to by doing this problem another way over to the left. If I take x to the 3rd and change it to x times x times x, because that's what x to the 3rd is, and I take x to the 7th and I change it to x times itself 7 times, what I can do is do some reducing. This x will reduce with that one, this one will reduce with that one, and this one will reduce with that one. And remember, if everything in your numerator reduces, you're still left with a 1 up there, so this will be a 1 on top. And then x times x times x times x on the bottom is x to the 4th. So doing the problem, working our exponent subtraction rules, I get x to the negative 4th. But when I do it this way, using the reducing technique, I get 1 over x to the 4th. So this is showing me how I handle a negative exponent. Negative exponents are going to turn into fractions. So if you have something raised to a negative exponent, it's actually going to go to the denominator and become positive, and there'll be a 1 on top after that. Let me show you another example. So here's an example of one with numbers in it. So 2 to the negative 3rd. So following that rule that we just talked about, this would turn into 1 over 2 to the positive 3rd. Again, the negative exponent goes to the denominator and it turns into a fraction. 2 to the 3rd power is 8. So I could call this 1/8. All right, so that's another example of negative exponents, but this time with numbers. Now let me show you 2 last ones with that parenthesis stuff that I was talking about. All right, so here's our last 2. On the first one, I've got a 3x in parentheses being raised to the negative 5th. Down here, I've got 3x to the negative 5th, but there's no parentheses anymore, so there's a difference between these two. This first one, since the 3x is all being raised to the negative fifth power, this is just going to become 1 over 3x to the positive fifth power. Negative exponent moves to the denominator, turns into a fraction, no problem. This one, though, is a little trickier because only the x is being raised to the negative fifth power because there's no parentheses anymore. So what happens in this one, if you think of this as a fraction right here, the x to the negative fifth is going to come down here and become x to the positive fifth. The 3, though, is not part of that negative exponent, so it's going to stay put in the numerator. So this is just going to be 3 over x to the fifth. That's a little tricky, but you got to remember that only the negative exponent moves. All right. We like to try to always write our answers with no negative exponents. It makes them cleaned up a little bit, and a lot of times you'll see that. Not that we're going to be taking the state exam, but they like to make sure the answers are always with positive exponents there as well. All right.